With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, consider the situation shown in figure. The frame is made of the same material and has uniform cross-section area everywhere. Calculate the area of heat flowing per second through a cross-section of the bent part if the total heat taken out per second from the end at 100 degrees Celsius is 130 joules. Okay, so in the given question we have been said that the frame is made of the same material and has uniform cross-section area everywhere. That means the material will have equal thermal conductivity and equal area everywhere. Okay, now the second thing we have been given in the question is from the 100 degrees Celsius end the total heat coming out is how much? 130 joules. Correct. Now we have to find the total amount of heat flowing from the bent part. Correct. So drawing the equivalent diagram for the given figure, it looks like this. Okay, so the equivalent frame will be look like this. Okay, now the thermal resistance is given as L by Ka. Correct. Now from here we can calculate the thermal resistance for every resistance shown in the figure. Correct. So resistance for the part AB will be equals to the length of the rod from A to B is given as 5 upon Ka. And the resistance for the part BC will come out as 5 upon Ka. Correct. Sorry, for the part AB the length is given as 20. Okay, so it will be 20. It will be 20. Correct. Now for the resistance for the part C to D will be equals to 60 upon Ka. Resistance for the part DE will be again 5 by Ka. Okay, now the resistance for the part BE will be equals to 60 upon Ka. Resistance for the part EF will be equals to 20 upon Ka. Now we have calculated all the resistance. Correct. Now look at the figure that the part BC, CD and DE are connected in series. Correct. This one is connected in series. So let us suppose its equivalent resistance is R1. So R1 will be resistance by the part BC plus resistance by the part CD plus resistance by the part D to E. Correct. Now substituting the respective values, what we get is 5 upon Ka plus 60 upon Ka plus 5 upon Ka will be equals to how much? 70 upon Ka. Correct. Now the equivalent resistance will be transformed into like this. Okay, so in the equivalent diagram what we get is here resistance 1, which is the equivalent resistance. This one is the resistance for the part BE, here the resistance for the part EF, and here the resistance for the part AB. Correct. This end is maintained at 0 degree Celsius and this end is maintained at 100 degree Celsius. The total heat taken out given to us was 130 joules. Correct. Now let us suppose that the total heat flown from here is Q will be divided into these two resistance. Correct. Now let us suppose this one is Q1 and this is Q2. Correct. And these two are maintained between the temperature difference of theta 1 and theta 2. Correct. From here what we can say is the total heat Q will be equals to the Q1 plus Q2. Correct. Let us suppose this is the part equation number 1. Okay, now we know that the total heat will be given as the rate will be given as the change in the temperature between the resistance divided by the thermal resistance. Correct. So what we can say is the part Q1 will be equals to the change in the temperature upon resistance of 1 and Q2 will be given as the change in the temperature divided by resistance 2. Correct. Now here Q1 will be equals to delta T upon R1 is R1 we have calculated at 70 upon Ka. So 70 upon Ka. Correct. Now from here Q2 will be equals to delta T upon R2. R2 is nothing but resistance of the part BE and resistance of the part is we have calculated as 60 upon Ka. Correct. Now, getting the ratio of Q1 and Q2, what we get is delta T, sorry, we have written it wrong. So it is delta T upon 70 upon K, correct, divided by delta T upon 60 upon K, correct. From here what we get is Q1 upon Q2 will be equals to 60 upon 70, or we can say 6 upon 7, correct. Now we have got Q1 upon Q2 is equals to 6 upon 7. Now putting the value from here to the equation number 1, which is what? That is Q is equals to Q1 plus Q2, correct. Now from here what we get is Q1 is equals to, just a second, let me see, Q1 is the part from the bent part, correct. So from here what we get is Q1 plus, that is we have to calculate the heat from the bent part, correct. So from here what we get is 7 by 6 of Q1, correct. Now Q is given to us is 130 joules, correct. Now here Q1 take as common, and what we get is 1 plus 7 by 6, correct. On calculating it we get Q1 is equals to how much? 60 joules, correct. So this is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.